So hello, everybody. My name is Steve Chaika, and formerly I was the manager of Smart City for the city of Mississauga. And prior to that, I was the manager of the Data and Visualization Studio at the city of Mississauga's Planning and Building Department. So today I'm going to talk to you about something I'm calling the digital twin pitch. So imagine a world, if you will, where we have, obviously, through this conference, open data. Now imagine a world where that open data contains very rich LiDAR information. And imagine a world where eventually the province and the federal government is going to collect and maintain much of that LiDAR information on a fairly frequent basis. Now I want you to imagine the concept of Facebook and Microsoft building something called the metaverse. We're going to have 5G that's coming down the pipe in the next 3 years. And 5G is going to enable augmented reality. And so things like smart transportation, smart buildings, smart cities, ultimately real-time feeds are going to work their way into this digital twin. And so the problem statement here is in a very short, brief sort of sentences, how might we use 3D point cloud maps, or AKA digital twins, to support resilient asset management?
And when I met with 030 Solutions back in October, we talked about the possibility of doing a pilot with a small community in Ontario. And what we would do is we would create a massive point cloud digital twin umbrella. And from that umbrella, we would be able to use, well, LiDAR is one thing and imagery is another. So we were thinking of using the imagery in order to come up with a digital twin of a distributed network of assets. And the network of assets would include both the green infrastructure and the gray infrastructure. And what we learned from the workshop from the PhD students from Carleton's Visual Studio Lab is that that data does exist in order to do point cloud 3D modeling. And Nick is with us, and I'm going to put him on the spot to describe how he uses his expertise in neural network and algorithms to extract objects from this distributed network in the point cloud. So Nick, are you with us? Can you unmute and just give us a brief description of what we talked about back in October?
You mean extraction from different of different assets from the point cloud?
Yeah, from the imagery.
Yeah, so we can extract it. We use some computer vision algorithms and some neural networks to classify panorama images and point clouds, and then we use some point cloud heuristics and some algorithms in the point cloud itself to sort of cluster the objects, so you know which points are belonging to each of the different objects. And since these point clouds are geolocated, we can also geolocate the assets on the map. And depending on what's interesting, we can also figure out different other features of the assets. For example, what's on an electricity pole or something like this. Is this an answer to your question?
Yeah, that was because I was looking at the infringement of the natural assets on the built infrastructure. So that could be a pole, it could be a street. The picture you had in your deck was the telephone poles that have been destroyed by an extreme weather event. And we're going to see more of these extreme weather events in terms of summer temperatures over 30 degrees. And also we're going to see in the next 50 years, if we get the same climate here in Ontario that they have in Kentucky, we're going to see more tornadoes. And nobody's prepared for this. And in terms of when we renew the assets, when they reach the end of their life cycle, that's when you want to think about building resiliency into that asset management system. So this is what you guys have. You have that technology. And the other thing we talked about is, well, if you train this algorithm on data from Berlin, how does that transport to other communities where the imagery is not the same? And you guys had a solution for that. Can you briefly touch on that?
So you need to annotate training data probably. So we were also looking at Google Street View images to see if we can annotate them. Is that what you're referring to?
No, not Google. I was referring to your partnership with TomTom.
Yeah, exactly. So we, yeah, sure. So we worked at TomTom before, and they actually sell the data. So they have exactly the data that we can process basically, and it's probably also possible to do some annotation on that data. Plus, they have data available already worldwide. So.
Now that data is both imagery and LiDAR, correct?
Exactly, yeah. So it's panorama images and then a whole LiDAR point cloud. And
yeah.
It's a panoramic image every X meter, like 8 meter or something like this. So it's quite, it's a lot of data. They have a lot of data.
Yeah. And is that affordable for smaller municipalities in terms of accessing the data, paying for it, or are you allowed to describe that cost?
So far we're still talking with TomTom about prices. So it's not something I can answer on the spot. For sure, if you buy more data, then they're willing to give a discount. If you use pre-recorded data, it will be cheaper. So they also said, depending on the size of the project, they also have these surveying vehicles, right? So with enough, if the time frame is big enough and the area is big enough, they're also willing to talk about doing it.